Hello friends, good morning. Welcome to the sixth video session on unit number 5, that is multimedia authoring and data representation. Now this particular unit belongs to multimedia communication technique, which is final year electronics and telecommunication engineering subject for Solapur University, Solapur. Now, as I said, this is the sixth video session. Now, prior to this video session, we have seen the different contents of this particular chapter, like introduction to multimedia, what exactly multimedia is, the difference between hypermedia and multimedia. Then we have seen one of the well-known application of hypermedia, that is www or World Wide Web. Then we have seen the different protocols as well as the different languages used to write the web pages. Then we have seen the overview of multimedia software tool. So in that we have seen several tools for all the different kinds of media, like image, graphic, video, sound. So all these need several level of editing to process on it, to work on the that particular media. And whatever the paid or unpaid software tools, those are available in the market. So those we have seen in overview of multimedia software tool. Then we have started in last session, last video session, about graphic and image data representation, in which we have seen the image data types. So different data types of images that we have seen, that is 1 bit, the grayscale images or monochrome images, followed by the 8-bit grayscale images, followed by 24-bit color images and 8-bit color images. So all these different the data types of image we have seen. Now in today's session, let us go ahead with popular file formats. So what are the file formats that an image is represented by? So all those we will see for graphics and image popular file formats in today's session. So let us go ahead. It is taking a bit time. Okay, so these things we have seen in previous one. Image formats: 1-bit image, 8-bit, then 8-bit, then higher bit depth images, 8-bit color images. Now let us go ahead with popular image file formats. So there are various, like you can see here, there are numerous different file formats. Those are available in the market nowadays, and out of which one by one, in very short note, we will try to finish all. So let us start with the first one, that is graphics interchange format, or which is well known as GIF format. Now to begin with the graphic interchange format, which is initially only used for transmitting the graphic images over the phone lines via modem. So earlier when the network was not very much popular, or internet was not very much popular in that time also, in order to transmit the data over the telephone lines. So these kinds of graphic interchange formats or GIF formats tends to use, obviously with the help of modem only we used to use this. Then this GIF standard is limited to 8-bit, that is 256 color images only. So there comes the limit that you cannot go ahead with very high color depth images or high resolution images. So whatever the color image representation has to be there, it has to be with 8-bit, that is the quantization level here I am talking about. So 256 color images only used to be there, that color which is denoted by the 256 different quantization levels. Then GIF has two types. The original specification was GIF 87A, and the later version was GIF 89A, which now the initial one which was supports simple animation via a graphic control extension block of data, and which provide simple control over delay time, a transparency index, and so on. So software such as CorelDRAW allows access to and editing of GIF image. So whatever the earlier type, like which started in early era before internet working or internet, that was GIF 87A, which simply supports the image type which is represented in the block of data, where there will be several amount of pixels denoted by several blocks, and that way only data was represented. And that was the earlier image file format of GIF 87A. Now this is how the GIF 87 format goes. It starts with the GIF signature, like it will give you a hint whether whatever the GIF file that is using nowadays, if you talk about, so now we have two both the formats available, that GIF 87A as well as GIF 89A. So GIF signature will tell you what kind of image that you are accessing, like if it is GIF 87A or GIF 89A. So signature is, it's basically a 6 byte of data which will give you which exactly the file format that you are using, 87A or 89A. Then it is followed by a screen descriptor, which is basically a 7 byte set of flags which gives you the more details about that particular image, like what size it is, what are the characters which are logically being displayed. So all that information related to that particular image will be given by the all the insight images will be insight about that particular image will be given by the screen descriptor. Like here, if I talk about nowadays, if you click on an image and with right click and see the property, then this it will be denoted by certain value, like say 640 by 480, that way. So whatever the size of that particular image and the additional value related to that, that will be denoted in the screen descriptor, which is basically a 7 byte in size. Now, in order to fit into the several different parts of the screen, GIF 87A can contain more than one image definition. Like most of the other parts which have been used here, it may vary image to image. Like if certain images are there which are not of the full size what this GIF 87A standard format is, so there has to be certain filler data, like you might have seen the cinemascope concept, where additional strip we need to add over that. So that kind of additional value or need to be added, which may vary from the image to image. Then each image can contain its own color lookup table, a local color map for mapping 8-bit into 24-bit RGB value. Now here what I'm trying to say is if the image that we'll be using, if it is a 24-bit RGB image, but as GIF support only the 8-bit format, so in order to map both these images, we need to have a local color map which is going to map this 8-bit value with the 24-bit RGB. So that way that interchangeability is there, and that is the name itself indicate graphic interchange format. Now the next popular format here is the JPEG. Like we have seen in earlier chapter also, JPEG is one of the most commonly used file format nowadays because of its higher compression ratios. Like it is the most important and current standard for image compression, that is JPEG. This standard was created by working group of International Organization for Standardization, that was informally called as Joint Photographic Experts Group. So that is the full form of JPEG, that is Joint Photographic Experts Group. And it was basically a standard which normally people use nowadays because of its better compression ratios. The human vision system, like basically when we go for compression, or the reason we have already been seen ki why we do need to go for compression, like whatever the multimedia system that we will be working on, the platform for the same will be a digital platform. So obviously, whatever we will be working, if that is in digital format, we expect that it has to have better resolution, and in order to have that, we go for higher sampling as well as higher quantization level. That in order to represent one particular value, one unit value in analog, like say for example, we are working on a sound, then in order to represent that particular sound very accurately, we go for higher sampling and higher quantization. Similarly, if we need to have higher resolution of that particular image, then we go for collecting more and more number of samples, more and more number of pixels. And as we go for this, obviously the size of that particular file is keep on increasing. As we will be dealing with the digital data, so we need to work on the compression level very effectively, because the data rates for working, like controller need to work on that particular huge piles of data. So there the controller's limitation might come into the picture. Similarly, if such huge amount of data is there, that may result into the problem with the limitations of the bandwidth also. So in order to save all these problems, we tends to go for compression. And here JPEG is one of the standard for a compression, because it basically start working with the human vision system. Like it ensures that, or this joint photographic experts group ensures that whenever they apply certain compression, they study the entire human vision system, and they found out that if an monochrome image is there, or certain monochrome file they need to see, then there has to be very like changes in the grayscale human eye easily can pick. So resolution, as per as black and white is concerned, or black and white images is concerned, because there will be only one color, and if at all anything changes, like if at all anything changes between the gray value, it can be easily denoted by human eye. So finding the resolution or high resolution is expected in monochrome, while as there are different colors, human eye can easily distinguish between the two colors. So even though the resolution is low for color images, it's absolutely okay. And when we go for a low resolution, that itself indicate the data which we will be working will be very less, and which itself indicates that it can be very easily compressed. So what JPEG has done, the human eye vision system has some specific limitations which JPEG takes advantage of to achieve high rates of compression. The eye brain system cannot see extremely fine details if many changes occur within few pixels. We refer that image segment as having high spatial frequency, that is a great deal of change in x and y space. Like this is what exactly I was trying to say. If in between two pixel, or between the simultaneous pixels, if there are high rate of change, or if there are high changes, then those cannot be easily distinguished by the human eye. Now this limitation is even more conspicuous for color vision than the grayscale. Like for monochrome, it can be easily identified because we will be dealing with only one kind of color. So with monochrome, identifying the changes is very easy, but in case of identifying changes is very easy, so resolution has to be very high, and for color it has to be very low. So now this limitation is even more conspicuous for color vision than the grayscale, that is black and white. Therefore color information in JPEG is decimated, that is partially dropped, and then small blocks of an image are represented in the spatial frequency domain, so rather than x and y. So if you can say that earlier we will be working on the amplitude level with respect to the frequency, then we would have say for color images, if we work in a domain of x and y. Now when we switch back to the JPEG system, here we can see for color there is no much resolution is needed. So instead of going for X and Y domain, we'll rather prefer to go for U and V domain. Now that is the speed of changes in X and Y is evaluated. So how do we go for these changes? Like how do we switch to spatial frequency domain, that is U and V, rather than X and Y? That is explained here. That is, the speed of changes in X and Y is evaluated for low to high, and new image is formed by grouping the coefficients or weights of these speeds. So what it has been shared is, if you go ahead with conversion of X and Y into U and V domain, that if we need to go for completely representing an image into the spatial frequency domain, what do we do is we go for finding out the areas where high rate of change is there, and then we identify the area where low rate of change is there. So if we identify that way, that this is the area where the changes are very limited, and this is the area where the changes are very high, then we go for weighing them with a different coefficient or different factor. Like what simply, let me put it in very simple word. If there are certain values in terms of the changes in the frequency side, let us consider that the values are like 1, then 3, then 5, 7, then 55, then 50, 90, 95, then 112, then 180. That way, if the values are consistently getting changed, and high rate of values, the changes in the values, if we observe between say 120 to 180, so this is the area where maximum amount of values are there, where changes are there, and there are less number of changes in the values, say from 1 to say 90 or 100. Then what we do, we identify the low change area and the high rate of change of area, and then we divide them by an factor which will obviously be high factor, so that area where low rate of changes are there, those can be easily ignored, and that way we can have more and more amount of compression. That is what is explained here. The weights that corresponds to slow changes are then preferred using a simple trick. Values are divided by some large integer and truncated. Say for example, the low area, the low change area is say from between 1 to say 50. Then 1 to 50 are low change area, then we will divide them by a very high integer, so that let us consider we are dividing them by say 200. Then 1 divided by 200, its value will be very very less, which we can easily ignore. So that way 1 will be out of our context. So we can say the value where 1 is there, we have compressed it because we have truncated it to 0. So that way we identify the area where low rate of changes are there, and then we divide them with higher integer and we make them to reach to a value 0, and that way we achieve the compression. So weights that corresponds to slow changes are then preferred using a simple trick. Values are divided by some large integer and truncated. In this way, small values are zeroed out. That is what I'm saying. So if values say 1 to 50 is there, if we divide it by 200, so obviously that value will be 0 point something. And if that value is less as per our calculation, then we will make them equal to 0 only. Then a scheme for corresponding long runs of zeros efficiently is applied and compression is achieved, and that is what is done in case of the JPEG. Let's go ahead with the next popular file format, that is PNG, which is known as portable network graphics. Now as the name itself indexed highlights that portable network graphics. Now this came into the picture with large use of internet. Like when networking networking become very much popular, this file format was introduced, which specifically preferred for the exchange of images over a network where a different configuration, different system standards are there. So irrespective of the system standards, irrespective of which system that you will be using, this PNG file format can be transmitted from one system to another system. This portable network graphics PNG format is system independent image format. That is what I said, system independent. So it does not matter what kind of system configurations that you have, the PNG file format will work irrespective of that, which is result of increasing in popularity of internet streaming. This standard is meant to succeed the GIF standard and extends and it in important ways. Now this is very important. Now earlier one which we have discussed is the GIF format, which specifically work in the range of 8-bit, that is 256 color standard. Now PNG extend a support up to 48-bit color information. That means here 48 bits, that you can simply imagine, like 2:8, that 256 colors were their system, but now if it extends a 48-bit support, that means 2:48. So these many millions colors it can support, and that's why it become very very popular, because it gives you a very better color standard or very better representation of image into the for specific color images. So special feature of PNG file includes support for up to 48-bit of color information, which is obviously a very large amount of increase in the standard of color images. Then it also comes with the files with the gamma correction information. Now this is very important. Like earlier, the GIF format which we were talking about, where as system changes depending upon the environment and all, so image does not change itself, or the gamma correction does not took place. But here in case of PNG, it also carry an information which include the gamma correction, so that when system changes, when display type changes, it can adjust itself, the image can adjust itself into the brightness feature of it. Like every color has its own brightness, so gamma correction help the image to regain the original brightness. So that kind of support is also extended by in this PNG file format. It supports both the lossless and lossy compression with performance better than GIF. So PNG is widely supported by various web browsers and imaging software. So this is very very important file format, PNG, which easily take over this GIF file format, and which was specifically designed for the network. Now let us go ahead with the next file format, that is Windows BMP, that is Windows bitmap format, is one major system standard image file format for Microsoft Windows. BMP supports many pixel formats, including the indexed color up to 8-bit per pixel, and 16, 24 and 32-bit color images. So as compared to GIF, it is obviously better because it gives you the varying file pixel format also. Like it in case of GIF, it was only 8-bit. Now it has 16, 24 as well as 32. So it is available in all these different bit per pixel format. It make use of run length encoding. Now this we will be covering into chapter number 6, the different types of compressions. So there we will get into the more details of run length encoding compression standard. So it make use of run RLE compression and can fairly efficiently compress 24-bit image due to color image due to its 24-bit RLE algorithm. BMP image can also be stored uncompressed, so it gives you dual standard, like it can store uncompressed version also, and it can go for the compressed version as well. Then let us go ahead with the next file format, that is Windows WMF, that is Windows meta file, is the native vector file format for Microsoft Windows operating environment. WMF file actually consisting of a collection of graphic device interface function calls, also native to the Windows environment. When a WMF file is played, typically using the Windows play meta file function, the described graphics is rendered. WMF file are apparently device independent and unlimited in size. Now just a minute. This is the file format Windows WMF, in which it is associated with this function is this particular file format is consisting of collection of graphic device interface. That means if any the file format that any kind of play file format, like any kind of music has been played, so along with that if we support some associated graphics related to that, like whenever certain music is been played, it apparently have certain bars associated with the different frequencies which tends to move up and down according to the pitch of that particular music. So all that kind of support is been provided by this kind of file format. Now next is EXIF, that is exchangeable image file. It is an image format for digital cameras. Now earlier file formats that we were earlier discussing was actually the file formats which was in analog domain, which then converted into the digital one. Now this exchangeable image file format is an image format dedicatedly for the digital cameras. It enables the recording of image metadata, so it ensures that all the information related to that image, like what is the exposure time, what is the light source, whether it was flashed or unflashed, the white balance, then type of scene. So all that, like whatever the nowadays which cameras, DSLR cameras, or even for mobile phone cameras that you use, once you capture the image and then if you go into the information details of that particular image, you tends to get all the associated data related to that particular image, which is basically deals with this particular file format, where it enable the recording of image metadata. So all the once that image been captured, so all the associated data related to that particular image will be stored or will be enabled in this particular file format, which is done for standardization of image exchange. A variety of tags are available to facilitate higher quality printing. Since information about the camera with the picture taking condition can be stored and used by printers for possible color correction algorithms. Now this is very much applicable where we deal with the image processing, where we need to know under what circumstances, under which condition the image was been captured, so that a different algorithm can be applied on it. The EXIF file format is incorporated in the GIF JPEG software in most digital cameras. It also includes specification of file formats for audio that accompanies the digital image. So here this EXIF is already incorporated into the JPEG software. Like whenever we take any image in a digital camera, so once that image has been taken, we actually tends to see that particular image, and when we click the information about it, then we get all the associated information about it. So capturing the image and storing that will deal with the JPEG, and the information associated that will deal with this EXIF file format. Now the next one is the PS and the PDF. So PS is this PostScript, and PDF we all like already discussed. In multimedia, Adobe is a very big name, so this PDF is associated with this Adobe systems, which is nothing but portable document format. Now this PostScript is an important language for typesetting, and many high-end printers have a PostScript interpreter built into them. PostScript include text as well as vector structured graphics. Several popular graphics programs such as Illustrator and Freehand. Now, if you recall, we have seen several software tools in this particular chapter number 5 only, in I guess fourth or fifth video series, where we have seen different software tools. I guess it is in fourth video series only. So in that we have seen the graphic tool for Illustrator as well as Freehand, and in that the PostScript has been used. However, the PostScript page describe language itself does not provide the compression. In fact, PostScript files are just stored as ASCII, which are in large size. So PostScript is basically the language for typesetting, and this particular file format store all the associated information with this particular image, which can be stored into the ASCII value. So once that image has been stored, the associated values will be stored in this ASCII format in PostScript. And then next is PDF, where whenever we tends to use the image along with certain text, then preferred way will be nothing but this PDF. So another text plus figure language has begun to take over the from the PostScript, that is Adobe system includes this LZW compression in its portable document format, file format. So for file containing images, PDM may be achieve higher compression ratios by using separate JPEG compression for image contents. Now here what PDF has done, it has applied the different compression for image and different compression for the text values, so that it has separated them, both of them, and then treated for the compression, so it achieve higher compression levels. So this PDF is obviously used over the PostScript. Then the last two types here we will be seeing, that is Macintosh Paint and PICT, that PICT. Paint was originally used in the Mac Paint program, initially only for 1-bit monochrome images, and PICT is used by MacDraw, a vector-based drawing program for storing the structured graphics. Then the next is X Windows PPM. Now this is a graphic format for X Windows system. Portable PixMap, that is PPM, supports 24-bit color bitmaps and can be manipulated using many public domain graphic editor such as XV. It is used in the X Windows systems for storing icons, bitmap, backdrops, and so on. So all these file format like X Windows PPM that I was talking about ensures that whenever we use operating systems like Windows, which is very much user friendly, so you might have seen in order to enter into the any of the drive, we tends to go for my PC. I'm talking specifically about Windows 10. So we tends to go on my PC, then we click it, then we see an image where the different drives been denoted, then we click on that, then we see several folders, and then we click on that, and we keep on accessing the files. Now basically it is not been structured that way. So those are the format of that particular OS, where with the help of several images, with the help of several symbols, we tends to access that particular file, which is stored in different drives, different folders, and different files. So this is very much possible with the help of the graphic format, which are specifically used by X Windows PPM format, where we can have the images, a small same images, which are basically a 24-bit color bitmap images for identify by several tools. So that is what the second last file format, X Windows PPM. And then last one is the graphic animation file. So A few dominant formats are aimed at storing graphic information, graphics in animation, that is series of drawing or graphic illustration, as opposed to video, that is series of image. Like as I told you, video is basically a series of images. So there are n number of images. Now when we talk about different color standards or different CCIR standards, so in that number of images we flipped for within the certain span of time, and that when we result into the continuity of the images which termed as an video. But there are changes in the graphic animation and the videos. The difference is that the animations are considerably less demanding of resources than the video files, because video files we need to run behind the continuity of the video, and every portion of that particular image is very equally important. However, for animation we did not have to depend on so many resources, so we need not have to run behind all the resources, so it's less demanding. However, animation file formats can be used to stored video information. Now FLC is an important animation or moving picture file format. Many older formats are used for animation such as DL and Amiga IFF, as well as alternates such as Apple QuickTime and animated GIF 89 files. So all are these, like, we are not expected to go very much in details of all these file formats. It is expected as per structure of this course to know the basic understanding of what are the different file formats that images and graphics tends to use. So for graphic animation we have FLC, DL, Amiga IFF, and for Apple we have Apple QuickTime and GIF 89 files. So I think this is enough for the popular image file formats. In next session, let us go ahead with the color science. In that we will see the different standards for the color, how we prefer to go ahead with different standards for video signals, for images that we opt for, like the for RGB is there, and then there are some other color models as well. So all those we will see in the next video session. So till then, thank you very much. Stay safe.